This video is of page 7. Number 1, about the crayon apple juice blend. So crayon apple juice blend is mixed in a ratio of cranberry to apple. That is important. Cranberry comes first, then apple, of 3 to 5. So when it says cranberry to apple, cranberry is 3 parts and apple is 5 parts. So let's complete the table to show different amounts that are proportional. So you're getting information into the table that needs to be proportional. So cranberry, remember, is the 3 parts, and apple is the 5, so I'm just going to use that one that was given to me. And then I can use what I know about ratios and making equal ratios by just like doubling them out. So if I take 3 and double it, that's 6. So if I need twice as much cranberry, I would need twice as much apple. And then I could say, oh, I really need a big batch, and so I need like 10 times as much cranberry, which would be 30 parts cranberry. And then I'd need 10 times as much apple, which would be 50. So there's infinite possibilities of things that you can have there in those boxes. Letter B says, why are these quantities proportional? So as we've been doing all along in lesson 2, we know that we can prove proportionality by using our ratios or our multiplier. A lot of people are tempted to go, oh, it's times 2 and times 2. That's how we got these equivalent ratios, but that's not how we're proving proportionality. You would have to look for some type of multiplier here, and it's not really easy to see one. So I personally think it's a lot easier just to write ratios. So I could take like the cranberry over the apple, cranberry over apple, cranberry over apple. Oh my goodness, this is a wrinkly piece of paper, sorry. I had crumpled it and thought I didn't need it, and I needed it. So if you take 3 divided by 5, whoops, I did multiply. 3 divided by 5 equals 0.6. And 6 divided by 10 also equals 0.6. And 30 divided by 50 equals 0.6. So what we see here is that we have the same decimal equivalent when we write all 3 of these ratios out. So we could say that they're proportional because there is a common unit rate. Now, if you'd chosen to use multiplier, you would have had to still divide to figure out what the multiplier was. In this case, if you're going to use this 0.6, you would have to show that it's 5 getting multiplied by 0.6. So it goes 5 times 0.6 is 3, 10 times 0.6 is 6, and 50 times 0.6 is 30. And at that point, you would have been using a common multiplier. But like I said, I didn't think that people would really recognize that there is a multiplier of 0.6 without having done these ratios.